Hello, Professor Karen. I hope you're doing great. This is Christopher, and thank you for giving me the opportunity to talk about the different swings between 1928 to 1929 to 1938 and what happened to the US GDP economy during these years. So I would like to start with the graph because that's a really interesting graph, and something that I want to talk about is that some of the probable reason why these swings and what happened during these years is that based on the research that I did is that between 1929 to 1938 this is the age when we had a big recession, which is called the Great Recession, which started in 1929, where the government spending, consumer spending decreased in a pretty linear way, as you can see here. And between this swing from 1932 to 1935, we had a pretty relative increase in GDP, which is shown by this linear growth. And during the years 1935 to 1937, we can see a curve which is definitely a quadratic function that we're seeing here. This parabola shows a vertex here, and which is definitely a non-linear function. We can see through the shape of the parabola, and also through the values, which are not linear. And however, as we see the continuity in 1937 to 1938, we see a pretty linear graph, and this is why I want to get to the next step, which is explaining how I have decided and what kind of math I used during these variables and these changes of values. So as we can start, I'm going to start with number A, which is here, and I want to start with 0, with the values of x being 0, since that's what you mentioned on the example. And we're going to not the already number, we're going to choose these variables, which is x as 0, 1, 2, 3, and up to 9. And this is relatively the GDP, and this is the value, but we're going to substitute 1929 to for 0 or up to 9. So as we start here, we are looking at the formula that we're going to use, and this is the slope, the variable of x, and this is the y-intercept. So as we start here, we start first by putting our variables, which is we start with number 0, and which is 1929, and the GDP at that point was 1050 in billions. And number 2 is the second point that we have here, is the year is number 3, and the GDP in billions is 750. And now once we know these variables, we choose the use the slope formula, which is this, and y2, this is y2 is this 750. We substitute minus y1, and divided by the change in years, which is year 3 minus year 0, which is 1929, and we get the value of 100. And next we're going to find the y-intercept, and to do that we're going to use this value, which is x equals 0, and that's when we get the y-intercept, which is $1,050,000,000,000 in GDP. So this is in the case of a linear linear function, because we see a relatively sustainable decrease in GDP, and we see a line in which helps us understand that this is a linear function. We do the same here. This is the same problem that I did here, and the same process. And for the third step, which is the parabola, I did not use the same system, because it is a parabola, and of course this is a nonlinear function. And to do that, we know that it's a down parabola, so we're going to use the vertex form, which is y equals a parenthesis x minus h squared, and elevated to 2 plus k. And as we do that, we start submitting the values, and that's when we do the math, and we substitute the values. And here we just substitute the values, and look rearrange to look for a. So once we isolated a, this is just simple multiplication, and I isolated a by translating all the data here to the other side, and that's when we got 1,000 minus 1,100. And since this basically gets eliminated, we only get 1. And once we're here, we get the value of a, which is negative 100. Now once we know the value of a, which is negative 100, we just substitute it and plug in the other variables that we had. So this gives us the function of the parabola. And pretty much here, the next step that I did is to find where it starts, where it ends the parabola, and where it starts up to 1938, which is a year of difference. So I did the same process that I did here in the first two, because it's basically the same. It's a linear function, and I got this result. And after that I just found this as my complete answer of putting all these variables together. So this is just a simple I made it as easy as a simple for me to understand and also to express. And one thing that I also have to explain is how I got these values, or the domains. And to do that, as I mentioned earlier, is that we are going to use the years starting from 0, and which is the day that we started graphing. So we're going to use that as 0 up to 9, and that's the basic expressions that we are going to use for us to plug in the domains, since that's the data that we use on all the all the information, all the data that we inputted in our variables. So from 0 to 3, that's the first expression that we went on to solve, up to the last year, which is 8 to 9. This is the 8 to 9 year. So that's how I submitted all the information, and based all the information that I gathered from here. And yeah, that's how I found the solutions. And I hope this presentation was great, and thank you so much.